To wrap up section 10.5, let's just review, because it's something we actually did way back when in 10.2 and kind of slowly mixed into some previous videos. But what happens when we are working with a situation where the radicals have different indices? So here's 3 examples where we do that. We'll talk about what we do, and like I said, it's something we've done before. So what we've learned, we're multiplying radicals here, but in order to be well defined, the indices would have to be the same. If they were the same, we would just keep the radical and multiply my radicands. But in this example, the radicands are different, the indices are different, and same thing here, right? Here the index is 5, and here it's 3, here it's 2, and here it's 3. So we're doing a multiplication, but we have different indices. So what we do is we use the old idea of converting these to their fractional exponents. And as soon as I make that conversion, we're now to exponential rules. I'm multiplying by the same base. So the product rule says to keep the base and add up my exponents. So there's basically the trick. And like I said, hopefully you remember doing that in 10.2 earlier this week. Of course, how to add fractions, we need a common denominator. So this would need 3 over 3, and this would need 5 over 5. So I'm going to be consistent with my little rule there of equivalent fractions. And so we would get 11 over 15 here. Again, follow the rule in terms of if we begin with radicals, my final answer should be in radicals. So there would be our final answer for that case. So if I'm multiplying the 5th root of x squared to the cubed root of x, we get the 15th root of x to the 11th. This satisfies all my conditions. The power inside is less than the index. They don't share a common factor. The radicand is not a fraction, right? And there's no radicands down in denominator. So we're nice and simplified. We're ready to move on to the next problem. Similar situation to the next one. Again, I have 2 radicals that are different indices, so I can't just put them underneath one hat. So basically, the trick is to rewrite this as a fractional exponent. So the x plus 2 would need to be in parentheses because it's the entire radicand. So the entire radicand raised to the half, and over here we have the entire radicand raised to the 1/3. And luckily what we're back to is the base is the same, and we're multiplying. So we're going to keep that base, and we're going to add my exponents. So again, in order to add fractions, we need a common denominator. So 3 over 3 and 2 over 2 will work. And we get 3 6 plus 2 6, and that all combines up to 5 6. Again, following the rule, we started with radicals, so I should end with them. So this basically becomes the 6th root of x plus 2 to the 5th power. Nice and simplified because all my rules are there, right? So the power is less than the index. They don't share a common factor. The radicand is not a fraction, and there's no radicals down in the denominator. So that's basically all we do. So like I said, we've done this before. So last example, again, we have a division statement, but the indices are different. So we can't put them underneath one nice radical like we learned because the indices are different. So we'll convert this to its fractional exponent form and see if that helps. Alright, so the power, right, and the power goes in the numerator, the index goes in the denominator, and same thing down here. And so the bases are the same when we're dividing, so that's a classic situation for our quotient rule. So we're now subtracting our exponents. Of course, to subtract fractions, I need a common denominator, so 3 over 3 and 4 over 4. We get x plus 1, I believe that's 9/12 minus 4/12. We get x plus 1 to the 5/12. Following the rules, end like you begin. We begin with radicals, so I'll end with radicals. This becomes a 12th root of x plus 1 to the 5th. And that's a simplified radical for all the good reasons. The power is less than the index. They don't share a common factor. The radicand is not a fraction, and there's no radicals down the denominator. So that's basically what we do. So a nice wrap-up exercise, kind of going back to 10.2. I think they just want, we've done so much where the radicals are the same. I think the book just thought it would be a good idea to kind of remind you guys that if we don't have the rule, if we don't have the definition, we can't use the definition. So a nice review of our fraction work. Okay, so that wraps up 10.5. And so again, as usual, if you have questions, if you have concerns, please email me, jump on Canvas and ask your questions, get your classmates involved, or email me. We can set up a Google Meet time to get you the help that you need.